I'm at NASA's Goddard Space Flight Center, where space lovers can not only see the sun, they can hear it as well.
The vibration is a very low hum. And the interesting part is, how loud would it be?
We all know the sun is the brightest object in our sky, but here's a secret, it's also the loudest. So why isn't it deafening us right now? We've got NASA heliophysicist Dr. C. Alex Young here to explain the silence.
It would be deafening. The sound it makes is roughly 140 decibels, which is pretty close to a jet engine. So it would be so strong that it would damage your hearing.
So how does it get measured?
The sun naturally vibrates, and by looking at the changes in the light, we can see the vibration. So we take pictures in visible light, and then we convert the oscillations that we see in those pictures into sound. That is the sound that you hear in the solarium exhibit.
What makes the sun so noisy?
The sun itself is not a solid body, it's a plasma. If you take, let's say, ice, a solid, you heat it up, you get liquid. And if you heat it up even more, you get steam. Well, if you heat it up a lot more, you then get a plasma, because you put enough energy into it that the individual atoms break apart into their constituents. However, they move.
If you could actually hear the sun, it wouldn't be a peaceful hum. It would be a constant, deafening roar. We're talking about massive amounts of churning plasma and exploding energy. It vibrates like a giant ringing bell. Wait, if it's that loud, shouldn't we be hearing it on Earth? It would be louder than a rock concert, right?
Electric and magnetic fields in it. And that means that there's all kinds of complicated motions that are happening inside of it.
Not only does the sun make noise, so does solar wind. There are 3 types of plasma waves that come from solar wind, and they all sound totally different.
If we look at a liquid or a gas, we basically just have sound waves. But in plasmas, because we have the electric and magnetic fields, we get very complicated.
Exactly. If space were filled with air, the noise here on Earth, 93 million miles away, would be about 100 decibels. That's like standing next to a jackhammer or a police siren 24/7. Yikes. So what saves our ears? The vacuum of space. Sound is just vibrating air molecules. But space is a vacuum, it's empty. There are no molecules to carry those sound waves from the sun to us. The sound travels a short distance in the sun's atmosphere, and then nothing. Total silence.
So depending on what's actually moving inside the plasma, you get all these different really rich types of wave structures.
The Parker Solar Probe, launched in 2008, collected this sound using its radio telescopes.
So it's been taking orbits around the sun. It's been flying closer and closer. It's gotten within several million kilometers of the surface of the sun. Cameras pick up all those different kinds of waves, and that is all recorded, and then we have this digital signal that then is transmitted back to the ground.
So it's screaming, but space hits the mute button. How do we know it's making noise if we can't hear it? We use heliosysmology. We don't use microphones, we use telescopes. We can actually see the sound waves vibrating the sun's surface, like ripples in a pond. We take those visual vibrations and translate them into data we can understand. We literally watch the sound. That is wild.
Why is it so important for us to learn about the sun through sound?
The sun can have a direct interaction with us. Large explosions on the sun can knock out communications. They can damage satellites and spacecraft that we depend on for GPS. And even in the most extreme cases, they can knock out power grids. So data of seeing what's happening inside the sun is helping us to understand how is it going to impact us. We can't live without it, and we depend on it every day, and it's, in some ways, it's one of the only constants, I think, in almost everybody's life. It's always there. Even if it's behind the clouds, it's there.
Dr. Young, thanks for helping us listen to the stars. Next time you enjoy a quiet sunny day, just remember, it's chaotic out there. If you like this quick dive into solar physics, Hit that like button and subscribe to Future Forward for more science that sounds good. See ya.
Welcome to Future Forward.